Hey guys, today we are going to start our next method of solving quadratic equations, which is solving with square roots. We have 3 steps, just like the last video. Step 1, isolate the x squared using inverse or opposite operations. And by that, I mean you're going to solve it just like you solve a normal linear equation. Step 2, take the square root of both sides. Don't forget the plus or minus sign. I'll explain that when we get to an example. Step 3, solve for x if necessary. A lot of times this step is not needed. So let's go ahead and jump right into an example. So our first one, we got x squared equals 9. Right now, the x squared term is all by itself. It's isolated already. So what we're going to do is take our equation. The only thing I have to get rid of is that squared. So what I'm going to do is take the square root of both sides. So this is my square root symbol. So by doing that, the x squared and the square root cancel each other out. I'm left with just plain x. On the other side, I'm going to take the square root of 9. The square root of 9 I know is a 3. But this is where we need to include both a positive and negative answer. And the reason I need to do that, if I think about 3 squared equals 9, but if I have negative 3 squared, that also equals 9. So because of this, I need to include both a positive and negative answers. We have 2 different ways to write this. One is the way I just boxed, or you can write it as x equals plus or minus 3. So if you are going to write it that way, just make sure you remember that that symbol tells you there are 2 different answers, a positive 3 and a negative 3. So let's move on to our second example here. We have x squared plus 1 equals 15. I'm sorry, x squared minus 1 equals 15. What I want to do is isolate the x squared. So if I look at the left side of the equation here, the thing I need to get rid of is this negative 1. That's what's next to the x squared. So I'm going to move that using inverse operations. So I'm going to add it to the other side. Bring down my x squared. These 1's cancel. And I'm left with 16. So now it looks just like this previous example. So what I'm going to do is take the square root of both sides. So take the square root of the left side and the square root of the right side. The square root of x squared, the square and the square root are inverses, they're opposites, so they cancel each other out. On the other side, I have the square root of 16, which is 4, or a negative 4. So again, you can write it out as 2 separate answers, or you can say x equals plus or minus 4. So let's take a look at 2 more examples. So number 3, we got 2x squared plus 3 equals 9. So this one, I have the x squared that I need to isolate. So if this was a normal equation, and by normal I mean if it didn't have that x squared, I would move the 3 and then move the 2. So I'm going to repeat that same process even though I have a quadratic. So I'm going to subtract the 3 first. And then I'm going to get rid of the 2 so that I'm isolating that the x squared. So my 2's get canceled out. I'm left with x squared equals 3. So now that I have my x squared all by itself, I can take the square root of both sides. So I take the square root of one side and the other. Over here, I'm left with just the x. On the other side, I can't simplify the square root of 3. It's not a perfect square. So what I'm going to say is x equals just the square root of 3, or x equals the negative square root of 3. And again, if you want to write it with our special notation, you can say x equals positive or negative square root of 3. And that is it for number 3. Now, number 4 is a little bit tougher. Normally, when I see this x plus 10 squared, normally I would want to write that out twice and then FOIL. So I'd multiply first, outside, inside, last. But what I want to do here is show you guys a shortcut. So let's get rid of all that. So the shortcut is to treat this just like you would treat this equation. So if my equation looked like this, I would divide both sides by 4 and then take the square root. So I'm going to repeat that same process here, even though I have this x plus 10 instead of a plain x. So I'm going to divide this whole side by a 4. And what I do to one side, I have to do to the other. So this 4 cancels out this 4. And the only thing I'm left with is the x plus 10 squared. On the other side, I'm left with just a 6. So I have my squared group isolated. So now I can go ahead and take the square root of that whole side. So my square root cancels out the squared, and I'm left with just x plus 10. On the other side, I'm left with plus or negative square root of 6, since that is not a perfect square and cannot be simplified. So this is where I have my third extra step to take care of. If I look over here, I still have x plus 10 instead of just plain x. So I need to move that 10 to isolate the x. So I'm going to subtract the 10 to the other side. Now, because one of these terms is inside a square root and one of them is not, I cannot combine them. So I'm going to write it just like I would read it. So I'm going to read it backwards. So negative 10 plus or minus the square root of 6. And there's nothing to be simplified since they're not like terms. So you would leave it as negative 10 plus or minus the square root of 6, and you are done. Now, normally you won't see this type of question. Normally you'll see questions that look closer to number 3. So make sure you know how to do ones that look like number 3. If you ever get stuck on a question like number 4, you can always multiply the whole thing out and then solve by factoring, or solve with square roots. I'm sorry, not square roots. Solve by the quadratic formula, which is going to be the next video. So good luck with our solving with square roots.